Assalamualaikum warahmatullahi wabarakatuh. Today, we are going to discuss about vector and scalar in architecture. Before that, I'm going to introduce the group members. My name is Muhammad Alif Qayyum bin Abdul Rahman. The second member is Princess Julie Anariki. The third member is Petros Ango Anak Marudi. And the final member is Nurul Hidayah binti Osman. First of all, we are going to start with what is vector and scalar. Scalar and vector quantities are used to describe the motion of an object. Scalar quantities are defined as the physical quantities that have magnitude or size only. Scalars are quantities that are fully described by a magnitude or numerical value alone. Vector are quantities that are fully described by both magnitude and a direction. So we have a example for scalar quantity and vector quantity. First of all, scalar quantity. Scalar quantity have a magnitude but don't have direction. So the example is that distance, speed, mass, energy, density, power, length, area, volume, time, temperature, and work. Vector quantities have magnitude and have direction. For example, displacement, velocity, weight, acceleration, force, impulse, pressure, momentum, gravity, and drag. Next, we are going to proceed to application in architecture. A scalar processor is a processor whose instructions operate on a single data. A vector processor refers to a processor that implements instruction operating on an array of data.
Example number one. So the question is, what is her total displacement from her starting point if you measure the distance along a straight line? Okay, for this question, we will let A be the first leg of the journey and B the second. What we are looking for is vector A plus B. We find that a determinant cos theta 1 is equal to 3 cos 53.1 degree and equal to 1.5 kilometer. Then we find AY. AY is equal to a determinant sin theta 1 equal to 3 sin 53.1 degree. And then we submit it. Then the answer is 2.0 kilometer. After that, we find bx. We same like a, b determinant cos 0 degree, because because the degree is 0, because there is no degree for the b, and the answer is 2.0 kilometer. Then same like same like ay at the first, by equal to determinant b sin 0 degree and equal to 0 kilometer. Then we write a plus b equal to, in bracket, ax plus bx comma ay plus by and equal to 3.5 comma 2.0. Then so the distance from the starting point is given by the Pythagorean theorem. So we want to find the c and let the c be the resultant vector. So same like theorem Pythagoras, square root c square x plus c square y and equal to square root 3.5 square plus 2.0 square equal to 4.0 kilometer. Then the angle of the resultant vector is theta 2 equal to tan inverse cy over cx equal to tan theta 2.0 divided by 3.5, and the answer is 29.7 degree.
So for the next question, as you can see, there's a triangle here. So AC equals to C minus A. Point B lies on AC equals to AB equals to 2 over 5 AC. Now we need to find OB equals to OA plus AB. OA plus 2 over 5AC equals to A plus 2 over 5 times C minus A. A equals to A plus 2 over 5C minus 2 over 5A. And you calculate this part, it will equals to 3 over 5A plus 2 over 5C. The reason why we got 3 over 5A here is because we simplified the A minus 2 over 5A, which is equals to 1 minus 2 over 5A. So when you calculate that, it will equals to 3 over 5A. And so next we convert it. We change the A and C into what I've already written here. A equals to 14 km, C equals to 15 km. So now for the next part, 3 over 5 times 14 plus 2 over 5 plus 15. And we calculate all of this, it will equals to 8 over 4 km plus 6 km and equals to 14.4 km.
The question is, a telephone pole support cable is in the way of some construction workers. In order for the workers to proceed, the cable must be moved 2 meters closer to the pole. If the pole is 10 meters tall and the cable is currently fastened to the ground 8 meters from the pole, how much will the workers need to cut off from the cable when they move in? Again, we have diagram to help clarify the problem. Okay, first, we need to find the original length for cable. So here, as you guys can see, so we use square root 8 square plus 10 square. So we will get 12.8, and then we need to find from here to pole. We still use square root, but we use 6 square plus 10 square, and we will get 11.7. The question asks to find the question asks how much will the worker need to cut off from the cable when they move in. So we just need to minus 12.8 minus 11.7. So the answer we will get 1.1. That's all. Thank you.
In conclusion, vector and scalar is very important in real life. It can assist us in the localization of people, places, and things. They are also used to describe things that are acting in response to an external force being applied to them. That's all from us. Thank you for listening to our explanation.